Hello everyone, my name is Ethan. Welcome back to the channel where today we are going to be continuing our journey in C#. Before the video gets too underway here, my bed is not made and my boy Monkey is not available. Here he is. Okay, cleaning my room right now, so that's why I'm currently washing all my sheets. So it's gonna look a little shoddy today, and that's gonna be how it's gonna be. So in the previous episode, we finished out our chapter on inferences and interfaces. If you missed that, be sure to go leave that one a like and a comment, and also go check it out, I guess, first before you leave a like and a comment, just in case you don't like it. We have just 2 chapters left, references and lists and LINQ. Let's just hop right into it. Introduction to references. What do you think will be printed by this code? So we have a new dissertation object. We're saying dissertation 2 is equal to dissertation 1. We're saying dis1 dot current page, perhaps an index or a property. And we would write out 16. But the answer is 16 and 16. We would have said maybe 0 and 16 because we set dis1 to current page, dis2 to 16, right? To understand what is happening here, we need to understand references. They might not be obvious in the code, but learning how to use them unlocks a whole new set of superpowers in C#. This lesson explains how references work in C#, why references are useful, and how to upcast a reference, as well as how to create a null reference. This lesson uses the book, dissertation, and diary classes and the iFlippable interface. Look through each to get acquainted. iFlippable is the interface, book is the base class, dissertation and diary are classes that extend the base class and implement the interface. So we got some stuff. Again, if you missed that chapter, it's the previous 2 videos. In video 1, I would have gone over interfaces, and in the second video, I went over inheritance. And I finished the project and quizzes in that video, which was 2 days ago for me, I believe. References of the same type. Classes are reference types. That means when we create a new instance of a class and store it in a variable, the variable is a reference to the object. Let's see what's happening behind the scenes when this code is run. So, for example, when we have a new class called dissertation, we create a dissertation object by using this code. A new dissertation instance, or object instance, is constructed and stored in the computer's memory. You can imagine a slot in your computer holding the instance's type, property values, etc. Dis1 is a reference to that location of memory. So dis1 is an object. Dis1 is not the actual object. It is a reference to the object. Thus, an object can have multiple references. So, boom, boom. Now there are 2 references to the same location in memory. We can say that dis1 and dis2 refer to the same object. If changes are made to that object, they will be reflected in both references to it. Right? So when we made some changes, the middle 2 lines of code are setting the current page property of the same object, first setting it to 0 and then setting it to 16. The last 2 lines will print the same value, 16. You can imagine references like directions to your house. They tell you where to find the house, but not the house itself. Create a new diary object with the current page of 5 using the constructor new diary 5. Store a reference to that object and name it dy1. It should be also type diary. So it wants me to create a new diary object with a current page. Here's the diary object, right? Okay, it just wants me to create the actual new diary object, so I'll get rid of the diary there. So what it wants me to do is do diary dy1 is equal to new diary 5. Create another reference to that object and name it diary 2. So we can just say diary dy2 is equal to dy1. flip dy2 by calling the flip method. It increases the current page property by 1. dy2 dot flip method. Now it wants me to write out some of the stuff, so we'll do dy1 dot current page. I didn't print out both though, so it's probably going to throw me an error. There we go. Very nice. References versus values. To better grasp the idea of reference types, let's look at another type of, or another kind of value types. While reference type variables refer to a place in memory, value type variables hold the actual data. Int is a value type, so its number num holds the value 6. Reference types, on the other hand, refer to a location in memory. Every class is a reference type, so the variable dis refers to a new location in memory that has the dissertation object. Every primitive data type is a value type, including int double bool char. Revisiting our metaphor, a reference is like directions to your house, which points to a house, isn't the actual house. A value type is the house itself. You may have noticed that string is missing here. It works a bit differently, so it will be covered in a later lesson. Very self-explanatory. All right, references versus values too. While reference type variables refer to a place in memory, value type variables hold the actual data. Let's put that in practice. Create a book variable, book location, that refers to a new book object. So we're going to create a new book variable called book location that is equal to a new book object. Loading, loading, loading. Wow, it's taking quite a long time to load there. Book object called same book location is equal to book location. So both variables refer to the same location in memory, which they do. Now let's create a bool variable called false value and set it equal to false. Variable holds the actual value. And now we'll create another bool variable called another false value and set it equal to false value. The false value was copied to a new location in memory for another false value to use. Got it. Reference versus value comparison. When we compare values with equals, the C# compiler performs a value comparison. For example, this prints true because the value 6 is equal to the value of 6. Int and int2 are the actual value 6. When we compare the value 6 with 6, they are the same. When we compare reference types with equals, the C# compiler performs a referential comparison, which means it checks if the two variables refer to the same memory location. For example, this prints false because D1 and D2 refer to two different types or different locations in memory, even though they contain the objects with the same values. We constructed two different dissertation objects which happened to have the same values. Each reference, D1 and D2, point to the different objects, so they are not equal. Let's create a variable B1 that refers to a new book object. Create a variable B2 that holds the same reference as B1. So to do that, we will do book B2 is equal to B1. And then we'll do console.writeLine and put the Boolean expression B1 double equals to B2. And it should print out the value true to the console. Yeah, so that's true because it is the exact same reference point, even though they are equal here. If we had created a new book variable, it would be a different reference point. References of different types. Before going any further, let's remind ourselves that dissertation implements iFlippable, which has the current page property and flip method. You'll need this info in a minute. In our previous example, both references to the dissertation object were of type dissertation. Whenever we used dis1 and dis2, we can handle the dissertation object as if it were a dissertation type. Since dissertation also implements the iFlippable interface, we can reference it that way too. So we can create a new dissertation object, right, called dis, and then iFlippable fdis is equal to dis. Now, dis and fdis refer to the same object, but fdis is an iFlippable reference, so it can only use iFlippable functionality. And then we have dis.flip, f.flip, fdis.flip, console.writeLine, dis.define. This causes an error. The last line causes an error because define is not a method in the iFlippable interface. The other lines do not cause errors because they use members that both iFlippable and dissertation have. This rule also applies to base classes too, so we can refer to a dissertation object as book. Title is defined for book, so no error is thrown there. Define, however, is not defined for the book class, so we can't use it with book references. This code contains two errors. Delete or comment out the errors causing, or the lines causing errors. Oops. So we create a new dissertation object called dis, or not, it's a new dissertation reference called dis. Then we create another one that is a copy, but it only has the iFlippable interface. And then we create a book object called bdis that is also equal to dis. So if we try to do fdis.currentPage, if we go to the iFlippable interface, we can use that one. So, but what about book? Does book have a page? No, it doesn't. So I'm going to comment that one out. Does fdis have stringify? No, it does not. Does this? Yes. So we're going to comment out that line. Perfect. Arrays of references. We know that we can use inherited classes and implemented interfaces to reference an object. Dissertation dis equals new dissertation 50, iFlippable fdis equals dis. This allows us to work with many similar types at the same time. Imagine if we didn't have this feature and had to flip a group of diary and dissertation objects or types. Look at all that code. It would be faster and safer if we store the references in an array and loop through it. But it would be an array of diary or an array of dissertation or something else. Since both dissertation and diaries are flippable, they both implement the iFlippable interface. We can create references to them as iFlippables. So we created references to them with iFlippable. Instead of dealing with an individual variable, we can use an array of iFlippable references. iFlippable classroom equals new iFlippable, and then we use it. Then to flip each element, we can write a for each loop, which we would do for each loop for each iFlippable f in classroom f.flip. We can only access the functionality defined in the interface. For example, we couldn't access f.title because title isn't a property defined in iFlippable. Create a variable books of book that contains dis1, dis2, dy1, and dy2. So I'll do that. We're going to do books equals new, would be new, yeah, new book with dis1, dis2, dy1, dy2. May have messed that up because it may want me to do, and it wouldn't be a video, guys. It would not be a video unless we forgot a semicolon. All right, we did that right. Let's make a for each loop. For each, it would be for each loop that loops through each element in the array. So it would be book in books. But what is this? What is books? Would it be a flippable book in books? Open that up. We'll do, and it wants us to start it off as an empty one. Doubt this matters, but the array is called books. Let's take a peek at the solution under the hood here. Oh. Doesn't book look weird, guys? That's my question. It doesn't look like a real word. Book is what it looks like. In the body of the loop, print out the title of each element. Perfect. Polymorphism. We just saw how useful it is to have the same interface for multiple data types. This is a common concept across many programming languages called polymorphism. The concept really includes two related ideas. A programming language supports polymorphism if objects of different types have common interface in the general meaning, not a C# interface, and the object can maintain functionality unique to their data type. Let's prove to ourselves that this is true in C#. We'll use the example of stringify, dissertation, and book have different stringify methods, but both can be referenced as books. Here are snippets from each code. Given that information, what will the program below print? We create a new book object and a new dissertation object. If we do book.stringify, it will just return this. But if we do it this way, it will return this book as an object. So, yep, this book is an object. This is a dissertation object. Perfect. Even though BK and BDIS are both book type references, their behavior is different. Dissertation overrides the stringify method, so all dissertation objects, regardless of reference type, will use that method. Therefore, C# supports polymorphism. In program.cs, there are book type references to one book and one diary object. First call b1.stringify and print it to the console. BK dot if this is a book object. Now call the same thing, but instead of B1, we'll do B2. Now it should say this is a dissertation object after, or diary object, right? Casting. So far we've referred to objects with a reference of their own type, an inherited type, or implemented interface. Boom. This process is called upcasting. As we saw in the last exercise, upcasting allows us to work with multiple types at once. It also lets us safely store an object without knowing a specific type. You can think of upcasting as using a reference up the inheritance hierarchy. What happens if you try to downcast or reference an object by a subclass? You'll need to do this when you want to access a specific functionality of a subclass. For example, what happens if when we refer to a book object as a dissertation type? Oh, looks like we lost connection to Codecademy there for a second. If we try to make a new book object and then do dissertation, new dissertation book is equal to book, it will produce an error. Not every downcast is possible in C#. In this case, dissertation has a defined method that is incompatible with book. This is the computer's way of telling you there's a chance this cast won't work. To get around this, you must explicitly downcast like below. The desired type is written in the parentheses. I see. This essentially tells the computer I know the risk I'm taking and this might fail if I'm not careful. In many cases, the downcast will still fail. Here, the dissertation type reference BDK can't reference a book object. So when we explicitly downcast, we see that it fails with a new error message. System.invalid cast exception specified cast is not valid. There are multiple ways to deal with downcasting, including the as and is operators, and we won't get into those now, but you can learn more about them in the Microsoft Programming Guide. Upcasting is creating a superclass or interface reference from a subclass reference. Downcasting is creating a subclass reference from a superclass or interface reference. Upcasting can be done implicitly, while downcasting cannot. In program.cs, dissertation and diary type references are being explicitly upcast to the book type. We know that those explicit casts aren't necessary. Delete the explicit casts from both lines. So the explicit casts are these ones right here. It wants us to delete the explicit class from both lines. I'm going to copy it just in case I don't do it right. Perfect. Null and unassigned references. So far we've seen a reference to an object, multiple references to an object. What a reference that refers to no object. In C#, a reference to no object is called either a null reference or unassigned. We'll need to apply these concepts in C# whenever we want to show that a reference is missing. Create a reference variable without defining it, or initialize an empty array. In the first use case, we'd like to create a reference that is missing or empty. We'll set it equal to the keyword null. In the second case, if we want to create a reference without assigning a value, we'll just do that. In the third case, if we want to create an empty array, each element is assigned a reference. Boom. Be careful when checking for null and unassigned references. You can only compare a null reference if it's explicitly labeled null. For the other two cases, comparing unassigned variable, we'll get error. Create a variable book type and set it equal to null. Book1 equal null or null. Print the variable to the console. Remember that null represents a null reference, so it should see nothing printed. Compare the variable to null using the equal sign operator. So we'll do console.writeLine bk1 equals null. Sure. Review. You've made it. References aren't always easy, but learning how to use them unlocks a whole new set of superpowers in C#. In this lesson, you learned that classes and interfaces are reference types. A variable of this type holds a reference to the data, not the data itself. This is different from value types like int and bool. The equality operator, double equals, is a referential comparison for reference types and value comparison for value types. Multiple references can be created for a single object. A reference and its corresponding object do not have to be the same type. For example, we can refer to a subclass object by an inherited superclass or implementation interface reference. The functionality available to an object reference is determined by the reference's type, not the object's type. Polymorphism is the ability in programming to represent the same interface for differing data types. Referencing an object is by an inherited type or implemented interface is called upcasting. It can be done implicitly. Referencing an object by a derived class is called downcasting. To signify that a reference is empty, we set it equal to null. If a reference is not sent to anything, it's unassigned. Perfect. Taking a second to load here. We'll see if it ever loads. This is pretty crazy. It's been very slow today for some reason. I don't know why. Very, very slow. Wow. That's crazy. That's crazy. It's actually not loading, so I will quickly do this. And try to go back. You guys can see what the profile looks like. But we have the C# thing here. Loading very, very slow today. And yeah, so it actually looks like, oh no, references still has a little bit more to talk about. But for right now, that's going to be it for this video. We learned about references. We're going to next learn about objects, which are a little bit different. So if you did enjoy this video, please be sure to leave a like, subscribe, and I'll see you in the next one. Peace out.